Hi, Bob. Can you please introduce yourself and tell me what you do at NorCon Tech?
So, yeah, my name is Bob Norwood, and I'm founder and chief technology officer at NorCon Technologies.
Great. What does NorCon Technologies do, and what kind of markets do you touch?
So NorCon Technologies is developing optical components for infrared optics. So, every day, our human eyes limit us to a very small part of the spectrum of electromagnetic waves, which we call the visible, and obviously that's very important to us. So we tend to have a lot of focus on that, and we have glasses and contact lenses and microscopes and telescopes and all sorts of other things that are built around the fact that we see light in this range that we call the visible. But there is a whole lot more that we do with infrared light and that people don't necessarily know about. I mean, everything from infrared scanners to infrared communications technologies to a lot of our aircraft rely on infrared light, because infrared light actually travels farther through the atmosphere, and you kind of know that because sunsets are red. And why are sunsets red? Well, because the red travels farther than the blue does. And the sky is blue because the blue gets scattered. So infrared light, which is even longer wavelength than red light, can go very, very far. It also has an interesting aspect of being able to be sensitive to the temperature of things. So infrared imaging is based on the fact that pretty much everything around us has a temperature, and a temperature, we can idealize that as just what we call a black body, which is really just what a light bulb is to a degree. And the hotter it is, the brighter it is. But so humans are emitting infrared light all the time, and that's why we're able to see, even though we don't have the temperature of a light bulb. That's why we can see humans in thermal imaging equipment. And this infrared optics area, really, my home in science and technology has been working with new materials and developing applications for those materials, so that we can all live better. Basically, our whole world is built around mastery of certain materials technologies, whether it's silicon for microprocessors or glass technology for fiber optics and all the visible optics I just talked about. The infrared world is a much kind of younger world in terms of the optics and the optical materials that have been developed for it, because there's a lot of difficulty in getting materials that actually will transmit infrared light. Most materials don't. So we've been working on developing infrared optical components, and we've been working with groups at the University of Arizona that have been developing these materials. And we've actually been looking at it more from the point of view of an optical component. And if you have these materials, what kind of lenses can you make? What kind of imaging systems can you make? Can you make really low-cost thermal imaging systems? Can you make optics that work better than the existing optical materials in the infrared? Maybe they're lighter, maybe they're lower cost, maybe they're easier to make into complex shapes. Those are things that we're very interested in.
Right. So just to give a little bit of background for people watching who may not know, the traditional IR materials or the infrared materials tend to be pretty hard to work with, or really heavy, or hard to find.
Yes.
And so where Bob's company comes into play is helping to make those more accessible and easier to work with, which is fantastic and very, very needed. Absolutely.
Yeah.
Thank you.
Yeah, and you can see, like, one of the so a lot of you have had your temperatures measured by infrared means over the last more than a year, and that's an example where our technology could make that easier to do, make it lower cost, because we're working with what are basically what we call hybrid materials. So they're kind of like plastic, but they're not quite plastics. They're kind of in between plastics and a certain type of glass. And that naturally makes them lighter. It also makes them, when you compare them with ordinary plastic, they actually have more what we call optical power than ordinary plastic. But they're a much lower cost, as you mentioned, than these relatively scarce materials that are often used for infrared optics, like germanium, for example. Germanium is a very expensive material, but it works very well, so people use it, but it limits the applications. You can't have these systems everywhere if it's based on that kind of optic.
Great. What kind of, so you had specifically mentioned like aircraft and defense. What kind of markets do you see this? I mean, so far I've heard healthcare too, right? You were talking about the temperature taking. What other kind of markets does this touch?
Well, one of the areas that so the defense area the defense area has been the traditional home of infrared imaging, and we don't see ourselves as being that promising there, primarily because that's almost entirely driven by performance considerations. And when you go to a new material system, you're going to have some trade-off usually in terms of performance and cost. I mean, pretty much everybody now wears plastic eyeglasses. They don't wear glass. Why? Because it's lighter. If you have glass lenses, they're very heavy. Now, if you had the glass lens and you had to heat that, if you had to be able to put your eyeglasses in the oven and take them out and have them still work, you would still use glass. But you don't need to do that. So that's an example. There's requirements in defense that you simply wouldn't need with a lot of other applications. So we're not really interested in that area right now for this system, precisely because it's more like a plastic. So certainly low-cost thermal imaging is an interesting area, and that touches healthcare. Another area that's interesting is it's a really emerging area, and you can see this now if you have one of the latest handheld smartphones, using infrared light, but not very far infrared light, for what's called 3D sensing. So the way the latest iPhone looks at your face is it has a bunch of little lasers in the phone that send their light out, and then they look at the light that scatters back from your face, and they use that information to figure out that it's you. And that's just one example of a really growing area that we broadly call 3D sensing. And it goes from everything from walking into a room and instantly being able to say, oh, this kind of couch is going to fit in here or it's not. I mean, those kind of things, which right now everybody doesn't have one of those. You don't have an app for that, but that's going to happen. It's going to change the way you plan space, the way you you sense things, and the security aspects to it. So we see that as one of the more interesting areas right now for our technology, and that's the one that I would say, have quite a strong interest from potential customers.
Very cool. So the next question I have is, what brought you and what brought NorCon Technology to Tucson?
Okay, that's a good question. I actually have to get something to show you in a minute. Well, actually, I can show you two things. What brought me to Tucson, and then what brought NorCon. I mean, literally, what brought me to Tucson was a phone call. So I was not looking. Actually, I had a startup company that I started around the time of the big internet boom in the late 90s, and this was located in the Philadelphia area, and it was as people who are old enough to remember that, which doesn't include you, there was a big bubble basically, and anybody can Google any stock of anything you want and look at their 20-year history, and you'll see this huge spike in the year 2000, Intel, Cisco, whoever it is, there's this huge spike, and then boom, came right down. So it was this big bubble that was fun while it lasted, and we had taken my company back down to about 5 or 6 people. And actually, my colleague here, Professor Pagan-Berrien at the University of Arizona, so I'm also a professor at the University of Arizona, just called me out of the blue late one December day when I was working on the basic asset sale of the company to myself, and said, "Hey, you ever think about being a professor?" And I said, "Well, yeah, maybe about 20 years from now." I mean, I really wasn't thinking about being a professor. I did have a long-term plan. So I came down here and I really loved the way that optical sciences was set up from a point of view of really being applied research driven, being very entrepreneurial, being a lot like corporate research labs were when I started doing my career about 15 years before that. So I thought, okay, this probably isn't going to come up again. This is like the best optics college in the world. If I say no, I'll probably regret it. But and so I just went for it, and did the kind of, went from a research professor, which, those of you in the academic world know that's kind of you got to raise money or you have to leave kind of position. And I was able to do that. And then I was fortunate enough to become a full professor more than 10 years ago now. And so NorCon, so that's how I came to Tucson. And I was born to be a desert person, actually. I mean, I just love it here. I don't mind the heat. I'm actually looking forward to the heat now. It's only like 82. It's like, when is it going to get hot? But NorCon, actually, it happened one afternoon. I was sitting in my office, and my colleague in chemistry, Dr. Jeff Keown, I've been working on this with for close to 8 years now. He walked into my office, and this is one of the early samples, which is completely beat up, and I've broken it a few times. But you can see there's a little bit of, I'm holding up this orange piece of plastic, and he walked into my office with basically this, and he said, "I think this would be really good for high refractive index optics." And I said, "Well, it's orange, so I can't use that for anybody's glasses. So what are we gonna do with this?" So I asked him what the structure was, and found out that a lot of it was sulfur, which I knew would be good in the infrared. And we took it over to the infrared detection lab, and at that time was housed in the McHale Center, interestingly enough, where the basketball team plays. And we compared it with an ordinary plastic, and it was so much better, just with the camera that they had there, that we were kind of off to the races after that. And so that day, I'd been thinking for a while, like, do I want to do a new company thing? And I kind of had that pretty much that day. I said, okay, this could be it. This could really be it. This could be a new company. And I was very fortunate a few years later to collaborate with a colleague to get NorCon started. And she did all the heavy administrative lifting and helped us get going. And then we've been now almost 4 years, and we have both an Air Force and a National Science Foundation contracts right now, and doing some interesting kind of work that's somewhat complementary. So they're sort of two different sides of this puzzle. And we're very eager to continue to grow the company and provide infrared optics for everybody. That's kind of the
I like it. I like it. You mentioned the kind of the entrepreneurial feeling coming out of the College of Optical Sciences, and I know you used to teach a class on that specifically.
I still do. I still teach it.
Oh, do you? Great. Well, it obviously is working. A lot of the people that we're talking to have come out of the U of A, or they've built companies based on the research they've done there. And it's really great to see that we're taking all of that spirit and we're putting it back into our community. And that's what this is all about. So
yeah, absolutely. So that's exciting to see that. And of course, we've been so fortunate to have Jim Wyatt as an example there, who brought his company up over a number of years, was very successful, and now is is giving back to us in just such an incredibly generous way through his support of students and new faculty positions. So to me, that's really just an amazing gift that he's given to us, and to continue to. And I know that he's such a big supporter of the entrepreneurial activity. So.
Yeah, he definitely is, and I mean, he's given back to the college enough so that they renamed it after him. So
that's correct.
So I mean, you've talked a lot about the things that you're doing right now and where IR materials fit in now, and a little bit about, I heard a little bit in there, but how do you see these materials fitting into the future? How do you see them affecting either the future of technology or the future of how we interact with our world? What do you see that look like?
Yeah, so I think we have a roadmap that takes us into more applications, basically, and that's going to depend on our ability to improve the material systems over time, and to come up with really unique designs that take advantage of this unique material set that we have. It's so right now I'm talking about sort of things you would hold in your hand, things that are basically stationary, not moving around. We see a future for this technology and what we're working on in particular in mobile applications, in things that basically vehicles. I mean, we've heard a lot about self-driving cars over the last few years, and I think the basic consensus right now is that it's not ready for prime time yet. I would agree with that, but having a readily available and easily deployable infrared-based scanning technology is one key part of those systems ultimately coming to fruition. And you'd be surprised. I mean, if you look at what those currently cost and what the limitations are, a lot of it is optics. It's optics based. It's literally the lenses that go into those systems are in some cases the largest single cost item, which is kind of weird. But if we look to go and change and really influence those markets as well. So I see this basic technology area, whether it's driven by NorCon, which we hope, or driven by others, I really see a lot of potential growth and real growth over the next 10 to 15 years. It's really going to change the way we interact with our environment and make everything more secure, more safe, more fun. I think all those things.
That's great. I mean, I think that's fantastic. And I mean, you even mentioned one of the things that they're talking about is having like scanners in the airport now to see if someone's running a temperature. And I mean, that very easily fits in there. I mean, it's
absolutely. I mean, there are practical considerations there where you need to, I mean, if you look at how accurately your imaging system has to work to be able to measure someone's temperature to the accuracy that you want, it's pretty demanding right now. But part of that is it's still pretty early in this technology area. So I think that there's a lot to look forward to from that point of view, and making our lives better and across the board. So yeah, I'm very excited. I mean, if you think about it, the visible spectrum, the infrared spectrum we just talked about spans a 10 times larger wavelength range than the visible spectrum, more than that. So it's a huge amount of information that's out there that right now, most of it we don't see it, we don't use it, and so it can only make things better if we can do that.
That's great. I love that. That's fantastic. So that's all the questions I had, but is there anything else you want to share or tell the general community about optics and photonics here?
I guess all I would say is that we are I think this optics valley idea is great. I think Tucson has done such a great job in bringing optics to the Tucson community's awareness, but also the world's awareness. And I think that optics and photonics, people hear those two words and kind of put them together. And optics is the big umbrella, and everything falls under optics. And photonics has been the place where I live. And I think photonics, when you think, you should think electronics is kind of a connection. So I think, so this is an example. So now I've got this other thing. So this is an example of a photonic wafer that we made in my first company. And if you can't really see it, but there's little circuits on that. There are little circuits on this wafer. And those little circuits basically carry light signals around. And the idea of photonics is to do with light signals what we do with electrical signals. Now, light's different than electricity, and we have the physics of that demands that we do things in certain ways. But you'll see more and more things that you're using every day that are going to actually contain photonics. The lasers that are in the iPhone, for example, are kind of a first wave of that. But that's going to continue, and you're going to see more and more of these, for lack of a better word, optical circuits entering your eyes. And you won't see them. You'll have to take stuff apart to actually know that they're there. But they'll be there, and that's going to again give us so much more capability to communicate and learn and succeed. So that's, I'm excited about what's happening there too.
Yeah, I was going to say, I think optics is going to play a really big part in how we communicate as we scale up our current networks to make everything more accessible.
It's going to play a bigger and bigger role.
Good. Well, thank you so much, Bob. We really appreciate you taking time to talk to us and tell us all about what you do and what excites you.